So as we observed in the last video, somehow we need to force progress towards completion, or else the skip command becomes the body of the loop, and that's just not going to get us anywhere. So how do we force progress towards completion? Well, in a lot of our algorithms we're going to be marching through a one-dimensional array for the moment. Later on we'll see what happens with multiple dimensional arrays. And often we will have what we would call a loop counter, a loop index, k in this case, that is either incremented or decremented every time you go through the loop. And if g then puts a bound on how large or how small that index k can get, then we have ourselves a bound function, and therefore we know that the loop will eventually complete. So there are 4 general cases that you will run into. One would be where the loop counter gets updated at the bottom of the loop, at the top of the loop, or decremented at the bottom of the loop, or at the top of the loop. And depending on which one of these you pick, you will potentially get a slightly different update in the loop body itself. Often that update is merely off by some adjustment to the index into the array that you are updating. Okay? So in summary, given Q and R, you derive the loop invariant, you force progress towards completion, which can then be guided by the choice of the loop invariant, because the loop invariant will often tell you whether you are going through an array forward, from 0 to n-1, or backwards from n-1 to 0.